Ready? Something going on here, but I want to get the 5 seconds, right? Right, so we're doing problem. Okay. Last week we finished up the stats, we finished up with the speed statistics, right? And now we're moving on to probability, right? That's probably one of the because we had based on the wording how the question is worded, right? Right, but I'll give them a few minutes again to those who have to walk up the hill and around. I don't like I'll start in a few minutes, right? Just give them a few minutes again, about 2-3 minutes again. Then we'll start, right? Right, in the meantime, if you want, you can take a look at the handout. Right, look at the probability handout and take a look at what we attempted this problem today. That's something that we then can you handle I guess we started, right? This is your handle. This is your handle that. All right, let's start now. All right, so today we're taking a look at probability, and then from the probability, we have to be able to do something called possibility space diagrams. And then we're going on to apply some rules of probability, right? So some of the rules of probability for one event, then we have to go over some Venn diagrams. So I'll have to show you back some steps, and then we'll take a look at questions that involve like tree diagram something, right? All right, so let's begin. It's up, are you okay there? Yeah, all right, thanks. I thought you were going to walk up here today. I didn't know there's something to go block down. But I say perhaps it's up behind. But it's like celebrate. How about you walk up? Or do we walk there? All right. So what is probability, right? The probability of an event is defined as the number of successful outcomes divided by the number of possible outcomes, right? And it's written by this, given by that small formula there. So for example, if I give you a die, right, and the die has 6 options, right? 1, 2, 3, 4, 5, 6. And I wanted to find the probability of obtaining a 5. Right? Again, it's a fair die, right? And a fair die has 6 options. How many 5s it has? 1. Right? So the probability of obtaining a 5 on a fair die is 1/6. Right? What's the probability of obtaining a value more than 5? More than 5. There's only one value more than 5, right? Right? And that is very much difficult in probability. Right? If we go in from using numbers alone, 3x minus 7, 9, 6, 4, so having to understand and follow which problem. Right? That's the only thing that really challenging the way they do it. Right. And just one more. If I said find the probability of obtaining something more than or equal to 5, what would that be? 2. Right? That would be 2 and 6. All right. You should also recognize that all probability lies between 0 and 1. So you can never get a probability bigger than 1, never get a probability smaller than. What does 1 mean? I'm going to tell you something as a probability of 1. What does that mean? Guaranteed it will happen, always happen, right? 1 means that event will always happen. And what does 0 imply? It will never happen, right? So 0 means never, 1 means always. All right? Nice. Good. So here's where the questions become a little bit difficult. Take a look at that wording on it. If 2 paired coins are thrown, find the probability that 2 heads are obtained, 2 tails are obtained, and exactly 1. So you have 3 things to find. 1, 2, 3. Right? But the problem with questions like this is sometimes you want to see what's going on. Right? So we have to learn to develop something called a possibility space diagram. That diagram shows you all the possibilities that can happen in this particular event. All right. So the question is we're going to throw 2 paired coins. And coin has what? Head and tail, right? Well, words are numbers on head and tail, right? We are looking at head and tail for now. So let's go back now and try to develop a possibility space diagram. Right? I'm sure you'll understand what's going on there. You'll see it? Right? Now making sense? All right, cool. So let's draw a possibility space diagram for 2 paired dice, right? Okay, what you'll do is let's study possibilities of each die. Right? So dice 1, possibilities of it. But let me do the one on top first, right? I'll go over this one for the coins. So you have 2 options, right? If I have a coin, you have either a head or tail. Right? That's coin 1. If you have coin 2 now, you have a head or tail. Right? And all these little things inside here are going to show you the possibilities that can happen. So here's possibility number 1. Possibility number 1 is that coin 1 is a head and coin 1 is a tail and coin 2 is a head. You write it like this: head, tail, head. That's okay. That's the possibility space diagram. Next option is a head on coin 1, a head on coin 2. So you have 2 heads. Okay. Next option is what? A tail on coin 1 and a tail on coin 2. So you write tail, tail. Okay with that? And the last option is what? Head on coin 1, tail on coin 2. You okay with that? So how many possibilities we have if we throw 2 coins? 4. Right? So the total number is 4. And if I said 2 heads, what's the probability of getting two heads? 1 on 4. Right? There's only 1, 2 heads. Are you okay with that? What about 2 tails? 1 again, right? What about a head and a tail? 2 of them, right? You have a head and a tail here, a head and a tail here. They all do already matter, right? So you'll get 2 and 4. That's okay? So to answer probability questions, generally you need to have a possibility space diagram. Sometimes we draw it like this. Sometimes we draw it Venn diagrams, right? I'll try to do what's on Venn diagram with other because I'm not sure if you remember everything. Okay, so that's the possibility space diagram, and that's what I try to do here for you. Okay, what you're gonna try for me now is to do a possibility space diagram for 2 paired tiles. Right? 2 paired dials are true. All right. See, Brianna, if we can do that, right? Do the possibility space diagram for 2 paired dials. Well, in the English people is 1 dice, 2 dice, or the other way around. Huh? 1 die, 2 dice. So die 1, die up. 1 die and 2 dice. I think die is singular. I think check it out. Huh? Check out the minute, that's quite good some ways like that. What's the first one I was gonna leave on and say, buddy? I fight. Roll of die. Roll of the word die. Good. So I have a good chance in English, so I one. Except data. So I get some more to do in English, right? 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 The little bit of room to leave some space for it, right? How many options do you have on a die? 6, right? So each one is 6. So see if you can set up a possibility space diagram. Yeah. Yeah, the one. They get Jeremy second one trying to answer. What a good man, thank you. I'll let's look for a. If I cancel then though, so I didn't cancel last yesterday. You know, how about 5? Let's have a 4. Oh, that's a level. This time, that's definitely. Oh, you don't like it. Right? When you write it, you can write it like this, right? 1, 1. Here's 1. Sorry. That should be 1, right? Write the value on side 1. Then here will be 3, 1. Right? Here will be 4, 1. Coming 5, 1, 6, 1. Problem does here long. Right, the possibility space diagram a little bit long, but right, so let's see how the rest of it will look. We got it. Next time, right? Right, so that'll be what? 1, 2. Right, try and speed out yours a little more so you can see everything, right? Okay. Right, so after we do, I'm going to ask some questions on it, right? The possibility space diagram will look like that. Sometimes you don't have to list it out, just put dots to represent everything. All right. So you could just put dots. But for now, I'm doing this because I'm going to ask some other questions on it, right? So that's 1, 5, 2, 5. Right. So nice. So what's the probability of obtaining the same value on the die? What's the probability of obtaining the same value, right? So the question I asked is this, right? What's the probability of obtaining the same value on both dice? The first question. What's the total possible outcomes Helena? What's the total possible outcomes in this? How many possibilities are there? Count it and see. Count all of them. 36, right? You have 36 possibilities, right? And how many with the same value of 6, right? Okay, what you can do, right? With a possibility space diagram, it's easy for you to, sorry, it's easy for you to kind of pick them up. Right? That's not normally grouped together. Okay? So the probability of obtaining the same value as 636, or you can simplify it if you want, right? Right? Online, are you okay with that? Joseph? Sabira, are you okay with that? Right? So remember, the purpose of this diagram is to help give you a picture of what's happening, right? Yeah? All right. So I know we didn't set it up like this, right? But here's what I want. I would like, and I'll make it first one easy. I would like to get the probability of obtaining a sum. Oh, I am. Right? Find the probability of obtaining a sum more than 10. Right? A sum more than 10. Right? So when you roll the dice, a sum more than 10. More than 10. Right? And as I said, they'll be grouped together, right? So you want to get a sum more than 10. Online makes the probability, you know. Again, it was there. Now let's know there was a play for one. Are we saying what about? Three. Yeah. Online or messaging anything there? Let me see online message. Nothing else yet. Oh, decent messages. Beautiful messages. Right? Check it back here, Ollie. Remember I said more than 10, right? So 10 not included. Right? Remember 10 not included. So the only options we have are 6 and 5, 5 and 6, 6 and 6. Right? So as I said, they normally group together like that, right? So the answer is 356. That's okay? Right? But you see the purpose of the diagram. Every diagram that we do in probability, that's the purpose of it. To make, right? To make your life easier. All right? Any questions online? Any questions here? Elena? You okay with that? Can you put there, Elena? Right? That's right. That's the way you handle questions like that. But again, when they show the two guys, the question can ask different things. The question can ask for the sum, the question can ask for the product, the question can ask for the difference, right? So when you set up your diagram, you can put in your value one time, right? Or when we do the party, but I'll show you. And I want you to do one more for me. Your possibility space diagram for a square die and a point. Right? And I want you to find the objective is to find the probability of obtaining a head and a value more than 4. Right? That's the objective, right? Find the probability of a head and a value more than 4. Do a possibility space diagram first. Right? Do a possibility space diagram first. Finish? Yeah, finish, right? Right, so you have your die. 1, 2, 3, 4, 5, 6. And you have your coin, head and tail. Right, so you don't have to list out all. You can just put these little dots to represent. Because you should understand what it does represent, right? Question said head and more than 4. That could only have one case. Correct? Yeah? And how many possibilities we have, Rihanna? So, how possibilities we have there? 12, right? Something is on the structure, please. Right? 12. So you have 12 possibilities there, right? You have 12 dots, 6 on top, 6 underneath. When you give it up, so that you put with a diagram, right? To help you, it's to help you see everything. Online, any questions? Some of you not send any answers, right? Like, so, wait, Severe, you there? What does it so? Severe, like, so sleeping up? Severe. Yeah, hold on, send something. Sebastian, nice, I'm very good. Severe, I'm here, right? Okay, nice. All right, so that's the way we do possibility space diagram, right? So I give that possibility part. Okay. That's okay. Probability, nice. Right, oh, that was from the first diagram that we did, right? Probability has 2 heads, 2 tails, and so on, right? Right, if 2 pair dice are thrown, right? We did this one, just check back the answers and make sure you agree. 2 pair dice are thrown, probability equal to 6. Is that correct? Equal to 6. Right, so 2 dice are thrown and the final sum. Equal to 6, more than 10, less than 12. If you agree with those answers or if any wrong. Sum equals to 6. More than 12, less than 12. All correct? So the last one wrong? Yeah, last one wrong? No. So, all right. So less than 12, so everything except 6, 6, right? Everything except 6, 6, so that's correct. Okay. Right? That should be 0 and 1. That T and I, that should be 0 and 1. Guess it's 0 the back end. All right. One thing I want to do now before I start 2 events, I'm going to go over Venn diagrams, right? I want to make sure you understand what each part of the Venn diagram represents. Right, then we will come back here. So head up on Venn diagram. I'm not sure some of you all did sexy. Let's go back, come on. Right, to head up Venn diagram. Right. So if you're doing Venn diagrams, we know that this represents what? What the rectangle represents? the universal set, right? So in this case, the Venn diagrams represent the sample space. Everything's possible. And inside here, that represents the event E, right? Outside here is the sample space. Here is the event E. What's called outside here? A prime, not E, right? E complement. Remember that? Outside here is what we call A complement, right? That's everything that's in the sample space, but not in A. Okay, right? So this here is everything in A. This is everything outside of A, but in the sample space, right? So suppose I wanted to get the number of elements in the sample space. What can I add up? All the elements in A and outside A. So I can add all the elements in A and all the elements out of A. That's okay? Okay with that? Suppose now I divide, watch this here, right? Suppose I divide every single term there by the number in the sample space. If I divide this by the number in the sample space, if I divide this by the number in the sample space, and this by the number in the sample space, what will happen? This is what? 1, right? This is what? That look familiar? What's the first thing you're writing about? What is this? Probability of A. This is the probability of A. Right? And what this is? Probability of not A. Okay? So you could call this not A, right? So therefore, the probability of not A is 1 minus the probability of A. Right? That makes sense? Yeah, and you see where it came from, right? So you can add this in here. Right? Copy it down because I want to make sure some of you all know about Venn diagrams, right? Copy it down. And let's see if we can move further into. Right, so what we see in there is for one event. I'm going to show you what happens when you have 2 events, right? And so we need to remember to find the probability of something not happening is 1 minus the probability of it happening. Okay. All right. So what do we do when we have 2 events now, right? So two events. We have the Venn diagram, we have the universal set, that is sample space, and I'm going to make them intersect. Right? Let's call this A and this B. Right? Everything in here is A, everything here is B. And I want to show you a few things before we do any calculations, right? So you might have to draw a few of these, right? Might need one more one. I'll see if we can. Right. First thing first. If inside here alone is shaded, what do we call that? Intersect, right? So again, if this is A and this is B, right? That shaded area there is A intersect B, right? It represents the region that A and B have in common. That's okay? Yeah. Next. What about right? What about here? What is shaded there? A alone shaded there. You're saying that? A shaded here. What is shaded here? The part of A that not overlapping B. What do we call it? We call it A only. Right? This is A, but it has some B in it. You'll see that? This is A with nothing else but A in it. Are you okay with that? But here's what we need. We need to find a way to represent this. We need to find a way to represent this using set notation. Any ideas? What is this shaded region here? We know for sure it has some A in it, right? Right? So A intersect what will give us that shaded region? A intersect something will give us that shaded region. What it is? Here's how I will find it doing it the long way, right? Here's A and here's B. So this is A, right? Correct? But I want to get something that will give me A only. So A intersect what will give you that thing? Anybody? Huh? B complement, let's see. B complement is everything outside B, right? So I'm going to shade B complement. Correct? Where it is the line cross. The lines cross in A only. You're saying that? Saying that? So therefore, A only is A intersect B complement. You're saying that? Yeah? So then there's a long way to do it, like shade one in one direction, shade the next one. And where two of them cross, that's the region where they intersect. That's okay? Okay with that? So what do you think will be B only? B. All right, A complement intersect B. You okay with that? Yeah? Last one. Well, it have more, but let's give me this last one. What do you call that? A intersect B. See, you know what? I should have given you one more. That's what I'm supposed to give you, and I'll leave it up. I squeeze it in one month up here. This will help you with that. What's that? A union, right? A union. Everything inside A and B, right? So what do you think this is? Sorry? A? No, not union. You close it. But and this is everything outside that. So can I say A union B complement? Yeah? No, not the same thing. It is not the same thing. Right? Or you could also say this. A complement intersects B complement. Can you say union? Say union. Huh? Oh, mine. Right. We are a little while. All right. So we need to know these separations. Everybody okay with that? Right? A union B, A intersect B, A only, B only, and the complement of A union B. Okay? This is everything outside A union B. Copy it down. Copy them down. Make sure you have all that. All right, so because sometimes in the questions they ask you those little things, right? So you have to know how to find the probability, right? So we're going to develop a formula for finding the probability of union first, A union B. Right? We need to develop a formula for that. Right, so for those who forgot, just make a note of what union is. Union is all the elements in both A and B. Sorry, all the elements in A and B. Right, union is all the elements in A and B, but no element is repeated. But no element is repeated. All the elements is A and B, but no element is repeated. So if they both have two, you can only write it once, right? Ready? So let's take a look at if we can develop a formula like this, right? I'm gonna click on data. So I need some help here, data. So I want to develop a little formula here for two events, right? So what is the number in A union B? How do I get the number of elements in A union B? We just said all the elements in A, right? Plus all the elements in B, but no repetition. So how do I get rid of the repetition? How do I get rid of the repetition? So if I have 2, 3, 4, and I have 3, 4, 5, 6. This is A and this is B. What is A union B? A union B is what? 1, 2, 3, 4, 5, 6. In writing it twice, right? You're not writing what they both haven't come on twice. So you're just writing 1, 2, 3, 4, 5, 6. Correct? Right. How do I represent that here though? Everything in A, everything in B, but I don't want repetition. So what to do? Because if I write everything in A and B, I write in 1, 2, 3, 4, 3, 4, 5, 6. Huh? Yeah, correct. So upside down set to minus A intersect B. Right? So if I minus A intersect B, I'll be left with this. Is that okay with that? A minus of a 3 and a 4. Because A intersect B is 3 and 4. Correct? So you're minus of one of them. One line? All okay with that? Yeah. So I'm gonna do the same thing again, right? Same thing I did here. I'm gonna divide everything by number in the sample space. So I'm going to divide everything by the number in the sample space. Here, I'll get the probability of A union B. So this is the formula I'm looking for, right? Probability of A union B is the probability of A plus the probability of B. Right? That's okay? So that's the first formula. Well, for the second formula after this that we need to do. Probability of A union B is that. Huh? And that is come closer. There. Am I ready to walk? All right, copy that down and then see if we can finish off this last thing I asked here. If A and B are mutually exclusive means they don't intersect. If A and B are mutually exclusive, see if we can finish that part of it. All right. See if we can finish this statement out here and we go to some questions. All right. Right, Tolia. What's he got there? What's the probability of A union B? But let's try something. So you will get A union B. Do they intersect? Do they intersect? No. But and the formula for A union B tells us this. But if they don't intersect, this value here is what? 0. So therefore, A union B is simply the probability of A right? Is the probability of A plus the probability of. That's okay? Nothing to do with intersect because intersect is 0. So make a note of that. Mutually exclusive means if you see that word, it means that A intersect B is 0. All right? Try to copy that down. one easy. Very good. And it have a light on it. All right. Let's give some questions on Friday, right? Question time. Let's start, right? All right, hold on. All these questions here too wordy right now, right? So I don't want to give it a second. Only you can handle some of them. But hold on now. Let's try some of these instead. All right, what is it? See that? All right, nice. So, for events A and B, it is known that A and the union and the intersect, and I wanted to find B. Right? So, cut off number one. Number one. Right? First thing first, right? I don't want to give you. They gave you the probability of A. They gave you the probability of A union B, the probability of A intersect B. you need to find the probability of, right? Write down everything they give you, and then see if you can figure out the little formula you use, right? Ready? So what do you think, let's pick on Rihanna. Rihanna, what you think there? They gave you A union B, they gave you the intersect, and they gave you probability of A. And they want you to find B. What's the formula you're gonna use to help you work this out? That's a good question. Now, I like to ask good question. But look at what you have. You have A union B, you have A intersect B, you have A and B. And you only have two formulas on the board. Gotta be one of them, right? Which one do you think will work out here? Which one I think will work out here? Or the side problem for those who going back home now in case of the when they get there, other different what having here, right? But they'll move it like that. They can even now so the other one. Yes, I'm talking English. Yeah. Talking English there, yeah. Rihanna, you only have two formulas on the board. Which one you will use? Right? You want me to union? So the probability of A union B is equal to the probability of A plus the probability of B. Right? And you have all those values, right? You have all those values. You can work in fractions or you can work in decimals, anyone you want. Right? A union B, that's 3/4. Probability of A, that's 2/3. Probability of A intersect B, we don't know the probability of B, right? A intersect B is 5/12. That's it. Just make probability of B substitute formula, right? That's okay. So questions are nice and simple when they give you when they don't have much words like this one here. I'll give you one with words just now, right? Right. So just make the probability of B the substitute formula. So that'll be 3/4 plus 5/12 minus 2/3. What is that? We can convert everything to 12 again. So that's what 12 and 5, 17 and minus 8. Plug it up, right? That's 6. 3 and 6, 9, and 14 minus 6, right? Yeah, 6 and 12. 6 and 12, which is a half. Online, you're with myself. Right, remember you started sending your answers, right? Severe, you didn't send any answers. Let me see, who said anything here before? Narayan, come late. You didn't send anything as yet? Jason, normally be listening. Jeremy, excuse Jeremy. Jeremy, excuse. Are you there? Good day, Jeremy. Please send some answers. All right. You are okay with the first one? Granted, you go on your phone. I'll bring you on the board. Sorry for. All right. On my end, I go on. All right. Next one. Try number 2. Right. This is number 2 here. Huh? Well, you can figure it out, but I give you the diagram here. I'll help you shortly. You should be able to get A, and if you look at B, C, and D, they're all shaded here. But try and get A. All I want is the answer for A. If you get B, C, and D, very good. Right? But I am mainly interested in A. Right? Brianna will do A first. And then Elena will help us get C. Then Nathan will do C. And if you keep complaining, you're going to do. Oh, we can know. Jeremy, I think it's something. Huh? Right? Take time to find it. But C, very similar to the one that I just did. Right? If you're trying to figure out D, right? B represents what? So part B. Part B, based on our shaded diagram thing. Huh? D only or C only? C intersect D complement will be C only. Yeah, part B here. Part B will be D only. Right? D only means what? You only want the part with D, right? C only, I mean. All right, okay. I meant C only. How do we get C only? What? C minus C intersect. Very good. What? C only is C and your minus of this intersect part here. That's C only. Okay, well, what's the diagram? Right? Just change the letters, right? Change the here. Take the union and minus the whole of B. Yeah, that could work. Take the union and minus the whole of B. Yeah, that could work as well. Right, Brianna, what you got for the probability of B? How much you got? Huh? All right. Right, so hopefully you have this 0. Hopefully you have 0.9 is equal to 0.7 plus the probability of D minus 0.3. How much you got for the probability of D? 0.5? Very good. 0.5. Next. Yeah, Nathan. So how we doing this here, boy, Nathan, right? That's C only. Right? So C only means you want C, of course, but you're taking out the what? You're taking out the intersection, right? So we can take C. So we can take the probability of C and minus off the probability of C and D. So that would be 0.7 minus 0.3. So I got 0.4. Correct? And if we use your method was C union D, which is 0.9 minus T, which is 0.5. And they got the same thing. Right? So you see how important those Venn diagrams are? Yeah? To finish out C and D, please. But this, I like. About to get a little tricky, yeah. About to go down. Finished? Oh, yeah. How we now Israel didn't come to the Kai in other system, Kai, that's where it comes there. Last one, I'm making no sense. Try to focus on getting that shaded part. Really, last one is the easiest. Yeah. Thanks, bye. So getting out. So getting out. Huh? Exactly. Oh yeah, tell me I'm waiting on you, for part C. Yeah, but you know, yeah. Yeah, well, three answers. Yeah. All right. Let me see what Jeremy said. Jeremy. You have it? Right. How we getting what is called C again, audience? Huh? Jeremy, book out this fast now. What is called D intersect C complement. It's just as simple, just like P. Kita one lagi usia itu di bandar. Ya login na. Itu di bandar. Jadi kami late. You will see them. Right, Mikai. I'll pick on you then. How we getting C? How we getting part C? Yeah, see it what in words. Part C. Okay, put it out already. Somehow I get that now. So C is D only, right? So like what? Yeah. What you guess? So you're taking D, right? You're taking D, which is 0.5, and you're minusing the intersect, right? And the intersect was 0.3. So yes, the answer that you saw there was correct. 0.2. And that's the reason why, right? All right, last part, Nathan. What is D? What is D? Look at the shaded, look at that shaded. Look at the shaded thing here, watch. And that's everything outside. Everything outside what? A union B, right? So how I will get that how I'll get that in. How you get everything outside? Okay, so A union B is what? Right? How much you mean it? In a whole triangle, in a whole rectangle. 0.1 remaining, right? So therefore, this is equal to 1 minus 0.9. How I know that is 1 because that's a universal set. That is sample space. Camera up, I begin. Well, you go to for that. And just there for that. Right? 1 minus 0.8. Finally, playing it. Somebody was that was the anyway, see you next class. If you have time to play it. Are you okay with that? Yeah? You have to learn the Venn diagram, that's all, yeah? All right. I'm gonna make it this before the exam already. Okay, right. All right. So from next week I'll go and study how to talk, right? Next week here's the words. Right? You have to figure out if the same is the set or if the same unit. Right? One is the Tuesday. Okay, one ticket from something very good. We want to on the group chat.
Oh, it wasn't
Stuff like that. What are the contact? One. Okay. Seven. Right, the one you can talk to them, I don't need to talk to them. Right, so okay. All right, online. That's it there for today. I don't realize I was done.